we have two linear equations and we're going to be solving them by using the method of elimination. So the first step is choosing to eliminate either the x term or the y term. So for this example, we can choose the x term and choose the lowest common multiple of 2 and 3, which gives us 6. We now need to multiply our first equation by 2. Now notice that this is the coefficient of the x term in the second equation, which will give 3x times 2, which will give us 6x. We can also do the same for our second equation, multiplying it by 3. If we multiply 2x by 3, we get 6x. So let's go ahead and write the two new sets of equations down. So 3x times 2 is 6x. 2y times 2 is equal to 4y. And finally 7 times 2 is equal to 14. For our second equation, 3 times 2x is 6x. 3 times minus 3y is equal to minus 9y. And 3 times minus 4 is equal to minus 12. So we now have two new sets of equations where our process of elimination can take place. So let's go ahead and do that. So the next step requires us to eliminate the 6x term. We can do this by subtracting one equation from the other. So for this example, we're going to subtract the second equation from the first equation. So 6x minus 6x gives us 0x. 4y minus 9y gives us 13y. And for the final part, 14 minus 12 gives us 26. So we can see that we can just take away the 0x term and we are just left with 13y equals to 26. We can use basic algebra to solve for y. So dividing both sides by 13, we get 26 divided by 13. So our solution for y is simply y is equal to 26 over 13, which is equal to 2. So writing this down in coordinate terms, we simply have 2. Note that this is the y point of the intersection of the two lines. Now the next step is to simply find the x point of the intersect of the two lines. So the next step is, since we have our y point, which is 2, we simply need to substitute y into any of the two equations to get our x term. So for this example, we'll use the second equation and substitute our value for y into that equation. So 2x minus 3 multiplied by our y value, which is 2, this gives us minus 4 according to our second equation. So 2x minus 6 is equal to minus 4. 2x is equal to minus 4 plus 6, which gives us a value of 2. Dividing both sides by 2, x is equal to 2 divided by 2, therefore x is equal to 1. So we've now solved for our value of x, and this is our x point. Our x coordinate is 1, so our point of intersection is the point 1, 2. So I've drawn down a rough diagram of the equations that we've just been solving. So the blue line is represented by the equation 2x plus 3y is equal to 7, and the green line is represented by 2x minus 3y is equal to minus 4. So recall that our point that we solved for was the point 1, 2. So we can check this on the diagram. If we go 1 across the x-axis and 2 along the y-axis, we can evidently see that the point of intersection is the point 1, 2 that we solved for, and this is how it makes sense graphically. So I hope this video has given you a basic understanding of simultaneous equations and what you're essentially solving.